Welcome back to episode 2 of Electrify Your Artwork. In this episode, we will be going through coding and sensors and some basic electronics. There are three parts to this series. It's advisable to begin at the first episode if you have not seen it. Short recap into what we looked at first episode. Looked at some iterations, some examples, and then learn the basics and the importance of input and output. Then we looked at what we need to begin, things like Arduino or Tinkercad. And we learned how to set up things for this class episode. All right. Hey, so this is my Arduino. It's a Maker Uno, and it is actually designed for school children. It's made in Malaysia, and it comes with labels to help us find the pins easily and debugging LEDs. Okay, so that means any signal that goes through the pins would be lighted up with the blue LED right here. Okay, so we will be making this today, but we'll put this aside for now. I want to introduce you to some of the components that we will be using. We have lots of LEDs here, right? So in an LED, just like a battery, we do have a positive and negative terminal, okay? This is important because if we put it the wrong way, it will not work. Okay, so another thing is we have other things like resistors, okay? Because they protect the circuit from getting too much charge. So they protect, in this case, the LEDs from burning out, okay? And resistors do not have a positive or negative. That's important to note. And we have a switch. A switch, we'll talk about this later. So on an LED, it's important to note that the long side, long leg, one long and one short. The long leg is the positive side and the short leg is the negative side. Also, if we cannot look at the legs, sometimes it's plugged in, we can feel it and we can see that there's a flat side here. I'm not sure if you can see. There's a flat side, and that would be the negative side of the LED. Do come in many colors. Nowadays, they even come in white and blue. Okay, now to the breadboard. It's a small breadboard. On a breadboard, the power normally goes this way, and you have the other two terminals at the side that go that way. Okay, so they go this way. And this is a switch, a button switch. You have a small one, and a big one. They are the same. They have four legs, and I'll use the big one because it's easy. The power goes this way. That means these two legs are connected. However, the button will connect. When press, it will connect the top part to the bottom part, okay? Both sides. So right now, not connected, but when we press it, these two terminals will be connected to the bottom, okay? In a hurry, you can just wire two. You don't need to wire four terminals because and very convenient that the spacing between the breadboard fits the switch with a cut in the center, so the power does not transmit across. So once again, on an LED, the long leg is a positive and the short leg is the negative. On a resistor, we don't have positive or negative. They can fit anyway. The purpose of the resistor is, of course, to protect the circuit from too much power. So let's look at the Arduino now. Okay. On the Arduino, we have two ground on this side would be the negative terminal and another ground on this side. Okay. We also have the positive side, which supplies 5 volts or 3.3 volts. That is the maximum on the Arduino. The other pins would be the input-output pins and also the analog pins. Okay? No need to know too much about it, just know that they input and output. Okay. The other thing that we need would be jumper cables. This is mine. This is a male to male one. Male meaning it comes with a stud, and female like this, it comes with a plug. So for this, don't be afraid. Just pull them apart and boom, there, you got your jumper. All right, so that's all for the electronics basics. Okay, remember, there's a positive and negative side to an LED, long positive, short negative. And now we'll look at some coding, basic coding, okay? It's hard to go through all the difficulty in coding in such a short time, but we'll start with the basics. And if you need, you can always look up more information. Okay, so how do we learn how to code? How do we start? So this is the process. Need a plan before we start coding, okay? Remember the input and output. So we code like that too, okay? So for the input, we need to understand what are the things we want to code in as the input. Remember this diagram, the input-output diagram? Okay. So before we start coding, we need to have a plan. When we have a plan for the input and output, then we can have an easier time with coding. Okay. Let's say to tell the code what exactly would be termed as an input. In this case, let's say a push button, okay? When push, something happens. Then we need to tell the code that is processed by the Arduino what to do when the button is pushed. And when the button is pushed, we need to tell it what is the outcome. In this case, when button is pushed, please turn on the light. Okay, we're telling the Arduino that. And when the button is not pushed, please have no light. And it repeats, okay? Repeats until it's turned off. Okay, so finally we get to look at some code, okay? So this is an example, okay, of a simple code that I wrote. So in coding, for the Arduino, we are coding in a language called C++, quite similar, okay? And at the end of it, we have this thing called a semicolon, okay? Every line has to have a semicolon to end. Curly brackets group things together. Okay, let's look. Forgot to tell about this. Double dash lines tells the computer not to read that line. It is used to write things for humans to read, okay? It doesn't read. That means it doesn't run that code with the two lines. and all lines should end with a semicolon. And statements that are enclosed in curly brackets are a block, okay, what we call a block. Sometimes there are curly brackets within curly brackets. So we have this one inside this one. Okay, it's easier to see in the Arduino software. It will mark which one and which is the ending for that particular code. Okay. It's generally good practice to space out the things so that we know like this is one thing, the big thing. Okay. In the code for the Arduino, there are two main parts, the setup part and the loop part. So that would be the setup part that only runs once during startup or when you power it on. And then there is the second part which loops. Okay, it's a loop. So it is continually running when the computer reads the first line and second line and third line and then goes back to the first line until it turns off. When it turns off, it stops running, and when you turn it on, it goes set up again. Okay. Run once, set up, run many times, loop. And the top part here is the place where I put parameters. I like to keep things neat and tidy, so I will put it there. Okay, more on the parameters part, okay? So in the parameters part, we normally put in the pins that we will be using. In this case, pin number 2 on the Arduino and pin number 12. And we assign names to it. Okay? The word here, constant, and int stands for integer. I like to put constant because this pin does not change on the Arduino. Want it to keep it until end. And the variables, they don't need a constancy. And integer means it's a full number, round and full number. If you want to use decimal places, you need to use another data type like long or float. Okay, long would be for big numbers, more than a million or so. So the first part here, we define all the things we want to define. Okay, pin numbers that we will be using, or the number of the pin that we will be using, and the name that we will be referring to. The name here, you can put anything, but as long as when the setup and loop is being run, we use the same name. Okay, so LED pin actually means number 12. It's just easier instead of writing 12 here and high. Okay, it's just telling the computer when I say LED pin, please recognize that and please remember that it is 12. I'm referring to 12. LED pin is 12. The right is the function and LED pin means 12 and I want high. High means on, okay? Again, on the important part would be some of this like input, output. Input means the Arduino will be looking for input. And output means that the Arduino will push out output, okay? Push out power. So once again, the first part, we define parameters, the constant parameters and the variables. Tell the Arduino what LED pin means and what button pin means and what button state means for now. Okay, button state is variable, so we have to set a value to it, set a 0 because change later, variable. Okay. First part, define parameters, put the double lines and tell the other humans or yourself as reminder what we are typing there. And we have the code to run once. If you tell the machine to prepare, the Arduino to prepare, that the pin mode is in input, okay? And the pin mode for the LED would be output, button pin, LED pin, output. Okay, and the last part is what to run continuously. So we are using a complicated one here, if and else. It's kind of like the real world, right? Like how we will read it in English. If button is on, please turn on the light. Or else, keep the light off or the light low. Okay, this one, it runs continuously until it's powered off. And press the button, release the button, it will turn on and off. Press again, it will turn on again. Okay. Okay. So if you do not have an Arduino, it's fine. You can use Tinkercad. I use Tinkercad all the time to type. This file, I will share this file in the description, okay? So once again, we do have the same code here in X, and we can run it on Tinkercad. Let's run it and try. Okay, plugged in, press the button. I don't know if you can see it, but the LED turns on a yellow. Okay, so let's look at the code and what happens. So we told the code, okay, button pin is 2, and we want button pin to be an input. So there we go. We follow the line and okay. And when there is power to pin number 2, please output at LED pin or pin number 12. Okay, output goes to the LED and the power goes back to the negative terminal or ground. And let's watch the loop again. Okay, the loop button state want the Arduino to understand whether the button has been pressed or not. So read input and I need to read that input whether it's turned on or off. And if it's on or high, and if and only if the double equal sign means if and only if must be high, and then we know that it's the instruction to turn on that LED. And if it's not on, not pushed down, the instruction is to turn off that LED. Okay. So this circuit here is the circuit for this code. Okay. Let's run through that. Okay. So we have two parts here: the LED part or the output part and the input part. Okay. The input part is below, okay, and connected to pin number 2. And the output part is above and connected to pin number 13. Okay, in this, we use a virtual breadboard where we have the power terminals, 5 volt and ground, connected to the positive and negative side here. Okay, goes all the way down. This one goes sideways. So we start with the input. Okay, so we have power going to the switch. Okay, one side, and it's not connected, so it would just go to the negative. No, yeah. So if there is no connection, there is no power. Okay. So when we turn it on, we press the button. So the power goes to terminal to pin number 2 as an input and goes the other way to out. Okay. And it's important to connect it to the ground so that it doesn't burn the input. Okay, because the machine is just looking for a little bit of signal, not the full 5 volts. And for the output part, we have the LED. Okay, we just need to power it on. So power comes out here at 5 volts, runs to LED and goes out. If and only if the button is pressed. Not pressed, no power comes out of 12. No output. Okay, simple, hard. Yes, I know it's hard. 90% of the people Most code, okay, on the Arduino can just copy and paste on the internet. I would like to you how to modify the code based on simple understanding so that you can just copy, paste, modify, sew together a few codes. Okay, so this is first code and the first circuit, and we have an input for the button and an output with the now for the next part of the class we would be changing this input into a sensor. For sensors, here is one of them. Okay, normally sensors come with 3 pins and power in, power ground, and output. An ultrasonic sensor, it looks like the kind you back of your car in a Jeep. This is a temperature sensor, so that is a temperature, and it has 3. DO stands for digital output, ND stands for the negative terminal ground, ECC stands for the positive or variable current. Okay, this is Tinkercad again. Okay, look at the one with the sensor. Sample here is free and would be available for all. Okay, so let's look at it. We still have the output still at pin 12. No changes on the output. However, the input have put the ultrasonic sensor. Okay, it's clear here. Signal 5 watt and ground. Okay, it's even simpler than the previous one where we had um, the button. So in this case, we just need an output. Don't need to put a resistor on it, and it wouldn't change much. Let's run the code. Oh, it's a bit more complicated here, but it's just paste and modify thing. Okay, so let's try. When we're running it, uh, it's that's the action distance, so we can play with it. The code says that if it's close, turn the LED on. Turn on, further off. Turns on when something gets near. Quite a useful thing because we can always replace the LED with another thing for your artwork so that when someone walks in front of your artwork, something happens. So this is the code that we are using for the sensor, ultra sensor. Hey, it looks complicated, right? Don't worry. The first part, again, before the void setup place, we put our parameters. Because in this case, there is a block of parameters, curly bracket and that bracket there. And that one is one block, okay? It's just to tell the code how to ultrasonic sensor. You can just copy and paste this from internet, many sources, always the same. Then we have this part. We put this in so that it can actually print out words on our serial monitor. I'll add that later. It runs once, okay? We just want to tell the code output on the serial at this number. That number is always 96. And we want the part where we look for the distance to run continuously. Okay? And since it's an ultrasonic sensor, this part here tells it the speed of sound as speed of sound remains pretty constant in our atmosphere as we are in a different quite minute, right? If the air is denser. But we know this calculation, so we tell it that if the distance of the sound reaches back at this speed, it is 1 centimeter. And we tell it to delay. Delay is like stop and pause for a while. Keep reading it only after 100 milliseconds. Okay, so it doesn't read like every second, be overloading the machine. Okay. And we want it to print quotation marks in characters M, and the data. Okay. Let's try it on the simulator. So Tinkercad again, start sim, let the code run, plugs in. So in this code, let's look at it. Have the serial monitor, serial begin the phase, and then we can see the serial monitor when you press it, it's telling it 149 centimeters, okay? And if I simulate the distance, okay, now it's saying 283 centimeters away, 37, okay, it's reading 37. Now that we know that the code is working and reading the distance from the sensor accurately, of course, then we can tell it process that distance and come up with an what to do with the output, okay? So I just put the term here, trigger state. Trigger state just means it triggers at this state, okay? Trigger state is equal to centimeter cm command, okay? It's a thing. I want to call it cm. So if trigger state is less than 30, that means if the distance is less than 30, turn on the light. If not, it low. Okay, let's change it, okay? And when I put it 30 to 7 cm, you see the light turns on. Okay, it's off. I can put it at maybe 60. Drop it to 60. Start the code again. Okay, you can see 183 cm on the serial monitor doesn't turn on. 200 turn on. 79 turn on. 65 turn on. 59 it turns on. Okay, 3 turns off. 4 turns. So once again, let's recap. In this lesson, we learned a lot. Learn about components, basic electronic components, a resistor, an LED, the long leg positive, short leg negative. Learn about the Arduino and pins and sensors input. On the other side, we learn about coding. We learn that the first part of the code is for parameters. Okay, is anything above that up is for double dash. Dash means the computer will not read it, and it's for human to read. And every other line read until the end, which is filled with a semicolon. What happens if I don't have one here? Tells you there's an error here. I cannot run this code at this line. But it normally points out the next line because it's the previous line that has the problem. They put that back in and press start. Okay. So again, debugging, when it says next line has a problem, you look for the previous line, okay? The line number is given here. Okay, once again, first part for parameters, void setup run once, void loop run continuously. Okay? Forget your curly brackets, your semicolon. Once again, I would like to thank Pemule, My Creative, and Cendana for supporting this project.